Dear students, welcome back for the fifth session for the chapter, that is the solid state. Okay. So in the previous session, I think I have discussed what are the various types of unit cell. They can be classified either the simple or it may be the centered unit cell. Primitive is also called as the simple unit cell, and then the another is called as what? The centered. So if the particles are present only at the corners in the given unit cell, then it is called as simple or primitive unit cell. Apart from that corners, if the particles are present other than the corners, then they can be referred as which one? The centered unit cell. Those centered unit cells are of three types, called as which one? Body centered unit cell, then face centered unit cell, and then the end centered. Suppose if the particles are present along with the corners, if it is exactly at the center of the whole crystal system, then it is considered to be the which one? The body centered unit cell. Suppose if the particles are present at the corners along with the centers of each phases, then it is called as a phase centered particles. Suppose if the particles are present not only at the corners along with but also at the opposite phases or centers of the opposite phases only, then it is called as end centered unit cells. Okay. Then based upon the values of A, B, C called as edge lengths, and then alpha, beta, gamma, that is called as axial angles. We are having today how much? The 7 types of crystal systems called as cubic, tetrahedral, orthorhombic, hexagonal, trigonal, which is also called as rhombohedral. Then we are having the monoclinic and then the triclinic. So from that we have decided the most symmetrical crystal system or the unit cell is found to be the cubic unit cell, because it has all the edge lengths equal. A is equal to B is equal to C, and all the axial angles are equal, and they are found to be mutually perpendicular to each other. That is, alpha is equal to beta is equal to gamma, and all are equal to 90 degrees. That is why it is the most symmetrical crystal system, or it may be the unit cell. Okay. That unit cell usually consists of 4 different types of particles called as corner particle, body centered particle, face centered particle, and then the edge centered particle. Edge centered particle. Then after we have calculated what is the contribution of each and every particle with respect to the cubic unit cell. For example, the contribution of a particle with respect to the cubic unit cell only, because as if we are taking only the most symmetrical, that is called as a cubic unit cell. If that particle, suppose if it is corner particle, if it is face centered particle, if it is body centered particle, suppose if it is edge centered particle, edge centered particle. So here the contribution of the particle, for example, the corner particle contribution is just only 1/8. Why it is? Because a corner particle is equally shared by 8 neighboring units, or 7 neighboring units actually. 7 plus 1, that is equal to 8. Means it is equally shared or contributed with respect to which one? The 8 unit cell which are very closest, or it may be the neighboring to each other. Therefore, the individual contribution of the corner particle with respect to the given unit cell is just only 12.5%. Indirectly we are mentioning that in the form of a fraction called as 1/8. Suppose if it is a face centered particle, its contribution is 1/2, means it is 50% of the contribution. Why? Because a face centered particle is shared equally by only the 2 unit cells, because one phase touches with the other. with respect to the given unit cell means its contribution means it is only the 50% or it is also equal to fraction in the form of 1 by 2. That is, face centered particle is shared by how much? 2 unit cells. Similarly, body centered particle, which is a centered particle which is exactly at the center of the cubic unit cell. Means it is no way touches or it is no way contributed with respect to the any of the neighboring unit cells. Therefore, its contribution is exactly 100%. With respect to a numerical number, it is going to be the 1. Means it is 100%. Whereas a edge-centered particle with respect to the unit cell is shared by 4 unit cells. It is shared equally by 4 unit cells. Therefore, the individual contribution of the edge-centered particle is just only the 25%. 25% means it is found to be the 1 by 4. So what these are? They are the contributions of the various particles like corner particle, face centered particle, body centered particles, and then the edge centered particles. Okay, so this is all what we have already discussed in the previous session of this solid state. Okay, now we are having the how to calculate the number of particles. General formula used to calculate the number of particles per unit cell per cubic unit cell. Number of particles per cubic unit cell is given by the formula. It is NB plus NF by 2 plus NE by 4 plus NC by 8. This is the general formula for the calculation of what? The number of particles that has been appeared are present per cubic unit cell. I don't know what type of cubic unit cell it is, whether it is a simple or a body centered or it may be the face centered, whatever it may be there. But here the general formula to calculate the number of particles per cubic unit cell is given by the formula NB plus NF by 2 plus NE by 4 plus NC by 8. Then what is it NB here? Number of body centered particles. Number of body centered particles. What is NF here? Number of face centered particles. Number of face centered particles. Then NE means number of edge centered particles. What is that? Edge centered particles. And NC is number of corner particles. NB refers to number of body centered particles, NF refers to number of face centered particles, and NE refers to number of edge centered particles, and finally the NC refers to number of which one? The corner particles. Okay. So here why it is just only NB means because the contribution for the body centered particle is just only 1. Therefore it is NB divided by 1. Hence it is NB. NF means we know that it is a face centered particles, number of face centered particles. So what is the contribution for each face centered particle that I mentioned previously? It is 1 by 2. Therefore it is 1 by 2 into NF is referring as NF by 2. What is NE here? It is the number of edge centered particles. What is that? Edge centered particles. What is the contribution for each edge centered particle for the given cubic unit cell? It is just only 1 by 4. Therefore what is 1 by 4 into NE? It is NE by 4. And finally, what is NC there? It is the number of which particles? Corner particles. What is the contribution for each corner particle? It is just only 1 by 8. Therefore, it is 1 by 8 into NE, that is NC, that is equal to NC by 8. Okay. Now we are going to calculate the number of particles with respect to either simple cubic lattice or body centered cubic lattice and then the face centered cubic lattice. So first one is calculate the number of particles per unit cell of simple cubic lattice. Simple cubic lattice. How to calculate the which one? Number of particles per unit cell of which one? Simple cubic lattice. So simple cubic lattice contains what? 8 LPs. What is LPs means? Lattice points. How much lattice points we are having? 8 lattice points, in which are situated at 8 corners of the simple cube. How many corner particles we are having? The 8 corner particles. That is, can I say that NC is equal to 8. NC is equal to what? 8. What is NC here? Number of which particles? Corner particles. Therefore, number of particles per unit cell of SC lattice. Usually, with respect to the cubic unit cell, I am deleting this because we are not observing any edge-centered particles. If it is simple cubic, the particles only at corners. If it is body-centered, the particles at corners along with body centers. If it is face-centered cubic lattice, it is the number of corner particles along with the face-centered particles. Therefore, we are no way concerned with respect to which one? The edge center. Therefore, just I am deleting that. Therefore, what is the formula here? It is NB plus NF by 2 plus NC by 8. Okay. Now, how many body-centered particles are there? There are no body-centered particles here because it is a simple cube, means the particles are only at the which one? Corners. Therefore, no body-centered particles, that is 0. Plus, how many face-centered particles are there here? No, as it is a simple cubic, means the particles are only at the which one? Corners. Therefore, it is 0 by 2 plus. What is NC here? Number of which particles? Corner particles. How many corner particles are present in the simple cubic lattice? It is 8. Therefore, NC is 8 divided by NC divided by 8. On simplification, it is 1. What is 1 here? It is the number of particles per unit cell of which lattice? Simple cubic lattice. Number of lattice points are 8. Number of which one? Particles per SC lattice is going to be just only 1. Why? Because there are no body-centered particles, there are no face-centered particles, but there are only the 8 corner particles. That is, NC is equal to 8. Therefore, it is NC by 8 means it is 8 by 8, that is equal to what? 1. Okay. So, let us have the second one. Calculate the number of particles per unit cell of BCC lattice. What is BCC here? The body-centered cubic lattice. What is BCC there? It is a body-centered cubic lattice. Okay. So here BCC lattice are the unit cell of BCC lattice contains 9 LPs. What are LPs here? The lattice points. What 9 are? The number of which one? Lattice points. In which 8 are at 8 corners of simple cube and 1 at the center of the which cube? Simple cube. Body-centered cubic lattice unit cell contains how many lattice points? The 9 lattice points. So here it contains only the how much? 8 lattice points, in which all are at the corners. All 8 particles at the corners. But here it contains totally how much? 9 lattice points. Among the 9 lattice points, 8 are situated at the corners. 8 are situated at the which one? Corners. And only 1 is present exactly at the which one? Center of the what cube? Simple cube. That is, can I say that NC is equal to 8 here? That is, NB is equal to 1. What is NC here? Number of which particles? Corner particles. How many corner particles are there? Just only 8. How many body-centered particles are there? 1. Means there are no what particles here? face-centered particles. Okay. So therefore, number of particles per unit cell of BCC lattice. Which lattice it is? Body-centered cubic lattice. What is the general formula again? NB plus NF by 2 plus NC by 8. NC by 8. Now, how many NBs are there? Number of body-centered particles are 1, because any body-centered particle is always equal to 1. Plus, what is NF? As it is a body-centered means there are no which particles here? Face-centered particles. Therefore, NF is equal to 0 divided by 2. Plus, what is NC? Number of corner particles. Again, the number of corner particles are how much? 8. Therefore, NC is equal to 8 divided by 8. So here 8 by 8 is 1, 0 by 8 is 0, 1. 1 plus 1 is equal to what? 2. So what is 2 here? The number of which one? Particles present per unit cell of which one? BCC lattice. What is lattice right here? It is the BCC. BCC means it is called as body-centered cubic lattice. Okay. So next we will move on to the third one, the same calculations. Third one I will write here and then we will have the calculate the number of particles per unit cell of FCC lattice. Which lattice it is? FCC lattice. How many lattice points, how many particles are present per unit cell of which one? FCC lattice. What is FCC here? The face-centered cubic lattice. Okay. The unit cell of FCC lattice, the face-centered cubic lattice. Continuation here. The unit cell of which one? Face-centered cubic lattice contains how much? 14 lattice points. How much lattice points? 14 lattice points, in which 8 are at 8 corners of the which cube? Simple cube. 8 are at the 8 corners of the simple cube and 6 are at 6 centers of face in the simple cube. How many lattice points with respect to FCC lattice? We are having totally how much? The 14 lattice points. Where the 14 lattice points are? They are situated in which among the 14, 8 are present at the 8 corners of the simple cube and 6 are present at the 6 centers of the which one? 6 centers of the face with respect to the simple cube. That is, NC is equal to 8, NF is equal to 6. What is NC here? Number of which one? The corner particles. Number of corner particles are 8 and the number of face-centered particles are just only here 6. Therefore, the number of particles per unit cell of FCC lattice. What is that lattice here? It is the FCC lattice. FCC lattice. It is NB plus NF by 2 plus NC by 8. NB plus NF by 2 plus NC by 8. That is equal to. What is NB here? Number of body-centered particles. As it is a face-centered unit cell means there is no which-centered particle? Body-centered particle. Therefore, number of body-centered particles are 0 plus. How many face-centered particles are there? 6 particles are present at the 6 centers of the 6 faces in the simple cube. Therefore, NF is equal to how much? It is 6. Therefore, it is 6 divided by 2. 6 divided by 2 plus. What is NC here? Again, the number of which particles? Corner particles. Again, how many corner particles with respect to any cube here? It is 8. Therefore, it is 8 divided by 8. So here this is 1, this is 6 by 2 is 3. Therefore, it is 3 plus 1, that is equal to 4 here. So what is 4 here? It is a number of particles per unit cell of what lattice? The FCC lattice. Okay. So that is, first you have to know what is the formula related to this. What is the formula for related with respect to the general formula to calculate the number of particles per unit cell in any crystal lattice. Either it may be SC or BCC or it may be the FCC. The general formula is what actually? It is NB plus NF by 2 plus NE by 4 plus NC by 8. But I have neglected which one? NE by 4. Why? Because among the 3 different cubic unit cells, what are the 3 different cubic unit cells we are having? Either the simple cubic or body centered cubic, or it may be the what centered? Face centered. We are not having edge centered particle. We didn't have a what particles here? The edge centered particle. Therefore, Ne is equal to 0. Therefore, the simplified form to calculate the number of particles per unit cell of any cubic crystal lattice is found to be the NB plus NF by 2 plus NC by 8. What is NB there? Number of body centered particles. Number of which particles? Body centered particles. Plus NF by 2. What is NF here? It is the number of face centered particles. Number of face centered. We know that each face centered particle contribution with respect to the given unit cell is always equal to what? 1 by 2. Therefore, it is just only NF by 2. And finally, it is NC by 8. Why? Because NC first refers to the number of which particles? The corner particles. Okay. So here, what is the contribution for each corner particle? It is 1 by 8. Therefore, it is 1 by 8 into how much? It is NC. Therefore, it is equal to NC by 8. Therefore, the general formula to calculate the number of particles per unit cell of any cubic crystal lattice is given by NB plus NF by 2 plus NC by 8. Now, we have to calculate individually. What's that? How to calculate the number of particles per unit cell of the 3 different types of cubic unit cells called as a simple cubic unit cell, body centered cubic lattice unit cell, and then finally the face centered. First, you have to be very first clear. What is that? What is simple cubic lattice? So the unit cell of the simple cubic lattice contains how many lattice points? 8 lattice points. How much lattice points? 8 lattice points, in which all the 8 lattice points of the particles are situated only at their respective corners. Because all the corner particles means all the 8 particles are present only at the corners. That is why the NC value is equal to how much? 8. Then apply the formula. What is that formula here? Number of particles present per unit cell of which one we are calculating? SC lattice. What is SC lattice here? It is a simple cubic lattice. What is the formula here? NB plus NF by 2 plus NC by 8. As it is a simple cubic lattice, no body centered particles, NB is equal to 0 here. There are no what centered particles again? The face centered particles. Therefore, NF is also equal to 0. Therefore, it is 0 by 2 plus. How many corner particles? NC is equal to 8. Therefore, it is 8 by 8. Therefore, 0 plus 0 by 2 plus 8 by 8. On simplification, we are getting only 1. What is that 1 here? It is the number of particles present per unit cell of what lattice? Simple cubic lattice. Similarly, we will work out with respect to which one? The BCC lattice. Okay. First, what the BCC lattice is? Any unit cell of the body centered cubic. Means it is the body centered cubic lattice contains how many lattice points actually? The 9 lattice points. Where those 9 lattice points are? Among the 9 lattice points what we are having, 8 are situated at the respective corners of the simple cube and 1 exactly at the center of the simple cube. 1 exactly at the center of the which one? Simple cube. So therefore, what are the values of NB and NC here? As we are having the 8 corner particles, means the value of NC is equal to how much? It is found to be the 8. And we are having only 1 body centered particle. Therefore, the value of NB is equal to what? 1. Okay. Now, apply the formula. How to calculate? Number of particles per unit cell of what lattice here? BCC lattice. Body centered cubic lattice is given by NB plus NF by 2 plus NC by 8. What is NB here? There is only 1. Which particle? Body centered particle. Therefore, NB is equal to what? 1 plus. As it is a body centered cubic lattice means there are no what for lattice points? The face centered cubic lattice points. Means there are no face centered particles here. Therefore, NF is actually 0. Therefore, it is 0 by 2 plus. Again, how many corner particles are there? Any cubic cell, unit cell always consists of how many lattice points? 8 lattice points. Therefore, NC is equal to 8. Therefore, it is 8 by 8. Therefore, NB plus NF by 2 plus NC by 8. On substitution, it becomes 1 plus 0 by 2 plus 8 by 8. That is equal to 2. What is 2 here? It is the number of particles present per unit cell of what type of lattice? Body centered cubic lattice. What lattice is? The body centered cubic lattice. Let's have the last one. What is that? How to calculate the number of particles present per unit cell of what lattice here? FCC. What is FCC here? The face centered cubic lattice. Face centered cubic lattice. So here first, the unit cell of face centered cubic means the unit cell of any face centered cubic lattice points, face centered cubic lattice contains totally how many lattice points? Usually we are having the 14 lattice points. Where those 14 lattice points are situated? Among the 4 lattice points, 8 particles are situated at the corners of the simple cube and 6 particles are present at the centers of the, how many faces we are having? 6 faces of the what cube? The simple cube. Therefore, what is the value of NF here? It is NC is number of corner particles, NC is equal to what? 8. And then the number of what particles? Face centered particles is equal to what? 6. NB is equal to 0 here. Why? Because there is no what centered here? Body centered, because it is an example for a FCC lattice. Then apply the formula. What is that formula here? Number of particles per unit cell of what lattice? FCC lattice. Face centered cubic lattice is given by the same formula. What is that? NB plus NF by 2 plus NC by 8. What is NB here? No body centered particles in case of FCC lattice. Therefore, NB is equal to what? 0 here. How many face centered particles NF are there here? It is actually 6. Therefore, it is 6 divided by 2. And how many corner particles are there here? 8. Therefore, NC is equal to what? 8. 8 by 8. So, on simplification, I will get the value as which one? 4. What is 4 here? It is the number of which one? Number of which one? Number of particles present per unit cell of what lattice here? It is the face centered cubic lattice, that is equal to 4. Okay. So, this is about the contribution of each and every particle per unit cell of the cubic system, and then how to calculate the number of which one? Particles present per unit cell of the same cubic system lattice, or the cubic crystal lattice, or indirectly it is the unit cell of the cubic system. Okay. So, first you have to make very clear what is that here. The thing is, don't confuse make the confusion with respect to which one? Either the number of particles and then the number of lattice points. Number of lattice points are always fixed. What is that fixed here? It is the fixed positions with respect to which one? The particle. But the number of particles varies with respect to which one? The cubic unit cell. For example, the number of lattice points, number of particles. You make it very clear here. Number of which points here first? Number of lattice points, and here it is number of particles per unit cell of SCL, BCCL and then FCCL. I will write that as a lattice first. That is, make a clear distinction there. Lattice. So here also we are having the same thing. What are that? SC lattice, BCC lattice and then FCC lattice. So what is that here? The number of which one? Either the lattice points per unit cell of SC, BCC or FCC lattice. The second case is the number of particles per unit cell of the same SC or BCC, or it may be the FCC. First, the number of lattice points per unit cell of SCC lattice is how much? It is 8. Number of lattice points with respect to unit cell of simple cubic lattice is 8. With respect to body centered cubic lattice, it is found to be the 9. With respect to face centered cubic lattice, it is found to be the what? 14. Here there is no formula to calculate the values of 8, 9 and 14 with respect to SC or BCC, or it may be the FCC, because they are already the fixed position of the particles. That fixed positions of the particles are called as which one? Lattice points. But how to calculate? There is a strict formula with respect to which one? Calculation of number of particles per unit cell. So here it is 1, 2 and then the 4. 1, 2 and then the 4. Means So it is not directly available, it is obtained only by the formula. What is that formula that we have calculated here? It is number of particles. It is given by the formula, what is that? NB plus NF by 2 plus NC by 8. Using this formula, we were going to calculate the which one? The number of particles present per unit cell of which one? The SC, BCC and then the FCC. Because in case of SCL, NC is equal to, I will make a clear distinction here, NC, NB and NF. SCL, BCCL and then FCCL. That is simple cubic lattice, body centered cubic lattice and then the another one is face centered cubic lattice. So here in every case, cubic unit cell. Cubic what cell here? Unit cell. Cubic unit cell. So here you make it very clear for us. If the cubic unit cell is SCL, then what is NC? In all the cases, first you have to remember that all has NC is equal to what? 8. Because each cubic cell, unit cell is first comprised of which one? 8 lattice points which are strictly at the corners. Means in all the cases, what is NC? 8. And in case of this one, 0 and 0 here. Why? Because no body centered and no face centered with respect to simple cubic lattice. If it is a body centered particle, 8 are at corners, 1 exactly at this, and there is no what centered? Face centered. With respect to the face centered cubic lattice, it is found to be the, what's that? Face centered cubic means no body centered, 0 here, it is found to be the 6. So with respect to the LPs, what is LPs here? Lattice points. Lattice points are 8, 9 and then the 14. Okay? 8, 9 and then the 14. Whereas, with respect to the number of particles, so same thing if it is like this, if it is a particles. Number of particles, this one to the 1, 2 and then the 4 with respect to this. Okay, so here this is the number of which points? Lattice points, 8, 9 and 14. What is 1, 2 and 4? They are the number of which one? Particles. So to calculate the number of particles, we need the values of which one? NC, NB and then NF. In all the cases, first NC is always equal to 8 because every cube first has its what particles? The corner particles, and deciding whether it is a simple cubic or a body centered and then the face centered, we are having the value of NB and then NF. If it is a body centered, if it is a simple cubic, first NB and NF are 0. If it is body centered cubic lattice, NB is equal to 1 and NF is equal to 0. If it is face centered cubic lattice, we are having the which one? NB is equal to 0 but NF is equal to how much? 6. Okay, so you make a very strict distinction. Don't make any confusion because there is a slight difference in the meaning between which and which. The lattice points and then the number of particles. Both are number of lattice points. Here it is a particles. Number of lattice points are the fixed positions, whereas number of particles means they can be calculated with the formula. What is that? NB plus NF by 2 plus NC by 8. Using this formula only we can calculate the number of which one? Particles. But the lattice points are always the fixed positions of the given fixed positions of the particles with respect to the given what cell? The cubic unit cell. Okay. So this is about the types of cubic unit cells. Then what type of lattice points that has been present in the 3 different types of cubic unit cell, and finally how many particles are present or how to calculate the number of particles present per unit cell of either the SC lattice or the BCC lattice or it may be the FCC lattice. Okay. So now we will move on to the closed pack structure with respect to which one? Solids. Because as if we know that Solid is one of the physical state of matter wherein the particles are how and how arranged, closely and compactly arranged. Means, what is a close packing arrangement with respect to the particle arrangement in case of the solids? How it is having the geometry with respect to the one dimensional, how it is with respect to the two dimensional, and how it is with respect to the three dimensional. Okay, so that all one dimensional, two dimensional, and then the three dimensional arrangement of the particles that we are studying under the topic that is called as closed packed structure with respect to the which one? The solids. Okay, so that we will discuss in the next session, that is the sixth session of this chapter that is called as the which one? The solid state. Okay, so thank you.